Towards next question, we are asked to find the cube roots of negative 64. Cube roots of negative 64. Question number 2. Cube roots of negative 64. Cube roots of negative 64. Let me write negative 64. Orthodox method by definition. Suppose x cube is equal to minus 64. We can write x cube plus 64 is equal to 0. It can be written as x cubed. 64 can be written as 4 cubed is equal to 0. Factorizing this, first bracket without cube, square of first, change the symbol, first into second plus square of second is equal to 0. We have first root, x plus 4 is equal to 0, x is equal to minus 4, and it is, by the way, the only real root. It gives us two complex conjugate roots, x square minus 4x plus 16 is equal to 0. Here a is equal to 1, b is negative 4, and c is equal to 16. Putting the value in quadratic equation, negative b positive negative, b square minus 4ac or all 2a. We have negative times negative 4, positive negative 4 squared minus 4 times a times 16 divided by 2 times 1. So we have something like this. Let me make some space for myself. I have x is equal to minus plus 4, square of 4 is 16, minus 4 times 16, it's 64 divided by 2. We have 4 plus minus, it will become negative 48, I think. 64 minus 16, 14 minus 8, it's 48 divided by 2. We have one root, x is equal to minus 4. We are finding the other two roots. Let's see and find out. 48, factorize 48, apply table of 2, again 2, again 2, again 2, means pair of 2 and another pair of 2. We have 4 plus minus negative 2 times 2 times 2 times 2 times 3 divided by 2. So 4 plus minus pair of 2, another pair of 2, and the negative 3 divided by 2. Taking 2 common from the numerator, we have taking 4 common from the denominator. Let me write, it will become 1 plus minus 1 plus minus under root negative 3 divided by 2. Cancelled out. We have x is equal to 1 plus under root 3 iota, and it is 2 times. We have, there is 2 times. Applying table of 2, 2 to the 4, or one can manage the fact from here, manage the fact as, I can write x keeping 4 intact 1 plus under root 3 iota divided by 2 there must be the minus, in order to get a cube root of unity. We know the fact that cube roots of unity are given by omega is equal to minus 1 plus under root 3 iota divided by 2, and omega square is equal to minus 1 minus under root 3 iota upon 2. Here the deficiency of minus, multiplying minus throughout, we have minus 4, it will become minus 1 minus plus under root 3 iota upon 2. So we have managed the cube roots of unity. It is, one is omega, other is omega square. So x is equal to minus 4, first one is omega square, or x is equal to minus 4 omega. So we have the final cube roots of negative 64 is minus 4 omega square. It is, by very definition, we have taken the long route in order to simplify this concept. We have the ability, we have the concept to attempt this as an MCQs. For an MCQs, it's really good to check the options, keeping in mind that sum of the cube roots of unity is equal to 0 and their product is equal to 1. Taking the first option, that is minus 4 times minus 4 omega square times minus 4 omega power 8. Taking minus 4 It will become minus minus plus plus minus minus. 4 for the 16, 16 for the 64, and I have omega 10. Omega 10 means omega cube times 3 times omega. So I have minus 64 into 1 cube into omega. So I have negative 64 omega. Negative 64 omega. Their product must be equal to minus 64. If these are the cube roots of minus 64, then their product must be equal to minus 64. Minus 64. Taking the other option, that's our B. We have 4 minus omega cube minus 4 omega power 16. Sorry, 4 omega power 16 minus 4 omega square. We know that omega cube is equal to 1. It can be written as minus 4. 15 can be written as 4 times omega cube raised 5 times omega, and that is minus 5 omega square. Omega cube is equal to 1. So we have minus 4 omega minus 4 omega square. These are the roots that we have just arrived. R1 can prove that. Multiply them. Minus minus plus plus minus minus. 4 for the 16, 16 for the 64, omega and omega square, it's omega cube. Minus 64 omega cube is equal to 1. So we have negative 64. Or you can verify their sum them, minus 4 omega square. Taking minus 4 common, we have 1 plus omega square. Knowing the fact that 1 plus omega square is equal to 0, minus 4 times 0 is equal to 0. So option number B is our right option. Just twist in the tail. We have to simplify omega power 16 as omega cube raised 5 times omega. 16 can be broken down as omega cube raised 5 times omega. It's equal to 1. 1 raised 5 is 1. 1 times omega is omega. And omega cube is 1. So we have minus 4 omega minus 4 omega square. Minus 4 omega square. So option number B is the right option. Bonus tip for you. 1 omega square also form a group under multiplication. 1 omega square forms a group under multiplication. For this, let me make for you case table. 1 omega square, 1 omega square. 1 times 1 is 1. 1 times omega. 1 times omega square. It will become omega square. Look at this. Omega into omega square. Omega cube means 1. Similarly, it will become omega square. Omega cube means 1. Omega 4 means, omega 4 can be written as omega cube times omega. It's also omega. So we have the inverse of omega is omega square, and inverse of omega square is inverse of omega square. Let me write. Inverse of omega square is omega. One is the identity under multiplication. Omega and omega square are the complex cube roots of unity. They are reciprocal of each other, or one can say that multiplicative inverse of each other. They form a billion group. Because omega into omega square is equal to omega square into omega. They obey the commutative law. Under multiplication. So it is a complex cube root of unity. They form a group under multiplication. Cube roots of any real number, they form a group under multiplication. Moving towards next question, we have